questions, so keep your hands up until I can order you.
I was worried about the first jump from the claim that you're interested in superluminal signaling to talk of locality in terms of the principle of common cause. I mean, for a start, the principle of common cause, as you said that, as Reichenbach said, so that doesn't say that C has to be in the past life code. No. Because only when you add that, you put it in the past life code. But in any case,
that's true.
It's a claim about what you say about correlations where there's no direct causal link.
That's
Imagine that an arrow straight across. And I would have thought the obvious non-local thing would be the arrow straight across.
Yes.
So in that sense, how is it equivalent to locality?
Well, I did, like, if we go back, I'm not sure if I understand, so I'll go back to where I defined that in a minute. So there was that option. So at the beginning here I say, if they can be in direct causal contact, that's the principle of common cause stripped of some of the things that I don't really need, that Reichenbach said. So I was saying, there could be direct causal contact between A and B, and indeed, you need the relativistic causal structure to complete Bell's argument, and you have to say that A and B are space-like and therefore cannot, and that therefore those two first things are ruled out. That's part of the argument. But then I think I gave that option, didn't I? So it was that's the first one. That's the blood drop. It's saying, okay, if I give up on relativity, there's a direct causal connection. But the point's supposed to be that then, what's the explanation of there being no superluminal signalling? There's no thing that you can point to and say this is a ban on superluminal causal influence in the story anymore. You've given up on having some principle you can point to and say that's a ban on superluminal causal influence. Right? And that's really the point. That's something that goes across all of these different approaches. There's nothing you can point to and say that there's a well-defined relativistic causal principle at work here. You just have to do without that. Is that satisfactory?
Yeah, I guess I misunderstood what you were saying about principle of course. I thought you kept referring to it as locality.
Oh, yes.
Yeah. But
yeah, so sometimes
it's confusing.
When I say locality, yes, so I suppose, in the back of my mind, I wanted to make it some kind of Reichenbachian principle of common cause plus the relativistic causal structure a lot of the time. When I say locality, that's kind of what that's at least Bell's formalisation of that idea of no superluminal causal. Yeah, I'm sorry if there was a terminology clash somewhere.
Right. So, I just wanted to get clear about the relationship to Reichenbach's notion of common cause. But when you said some kind of Reichenbachian notion,
yes,
that covers it. So there are all these people who've talked about the distinction between the common cause. So saying that for each pair of settings, there must be a common cause of that pair, which is sort of Reichenbach's principle, instead of classical.
Yes.
A single set of a pair of random variables. But then there's this common cause that is supposed to be a single common cause that covers it no matter how you set things. So maybe those two are equivalent in the context of some other assumptions that are made in Bell's argument.
I would say that the one of having uncommon common causes or whatever it is, just this common causes for each setting is not really consistent with the idea of locality being a lack of superluminal influence space. It doesn't really. Where did I have this? So this list of things I said that any locality must imply. I think that some of these definitions that people make, where they meddle with the Reichenbachian notion a bit and to try and take it away from Bell's, are problematic. I'd say. I don't know how much detail you want me to go into there, but I disagree that they're good ways of saying locality, because they, for instance, they're not robust under conditioning on past events, is one of the things. It takes a while to explain why that is, we can talk about it. But yes, I have disagreed with that school about that, so I think that there are actually problems with these other ways of defining things, and that's basically why I didn't mention that.
Okay.
So you had a slide somewhere where you were saying that like local causality is applicable to absolutely any theory.
Yes.
That's like something I've had shouted at me at various times. But
Yeah, I can imagine.
there's kind of a subtlety there in that if you say that the failure of local causality means something like superluminal influence, then local causality is not applicable to any theory. It's only applicable to a theory that like purports to be a complete description of all the relevant things. Like if you have a theory that's like it's just about the prices that various agents are using to trade things, and there's correlations between those prices in different markets.
Oh, I see.
And it's like, oh well, that's due to Bloomberg terminals, but that's just not included in my theory.
Yes, that's true. So,
So you wouldn't say that that theory had superluminal influence. It just doesn't include.
it's an incomplete theory in some sense.
So if you really want the like failure of local causality to be superluminal influences,
Well, I'd say.
then you need to be a bit careful about saying it's applicable to
Well, I might say that those things are the theory that you're using, if it doesn't include your Bloomberg things, it is non-local, just because it's not I subsume those things by saying, yeah, that's not a complete enough theory to have a proper causal account of what's going on. You need those other things. You need to put these new things in to really have a causal account. So I don't know. That's more of an issue of nomenclature, I suppose, than something really deep to me. But
Would you call it a superluminal influence?
is it? Well, it leaves. I'd still say it's a model which doesn't obey locality because the notion of locality is to do with the principle of common cause, and it's not satisfied there. So, yeah, I mean, you could if you want to say, oh, it also includes incomplete models, which it's waiting to be completed. But yeah, I mean, yes, they are purporting to be as good as they could be, and there's something incomplete about them which deserves to be completed. But yeah.
But in that case, I mean, if as part of your locality condition you had this notion of an agent being able to freely control one of the variables, that case is not going to pass that test.
Oh.
Because in the circumstances under which an agent freely controls one of the variables, the correlation is going to go away. Because there's the unexpressed common cause in the background.
So you mean because maybe you need to say, maybe I didn't get the point. So are you saying that if you knew everything about all of the variables in the universe in a sort of ontological picture, then no one's got free will? Is that not?
No. If you had a more complete theory where you had a description of the things which were influencing the market prices in the two locations,
yes,
then it would be clear to you, well, among other things, it would be clear to you why if you reached in and changed the prices in one market, you're not going to change the prices in the other market.
yes.
Because you'd be breaking the link with the common cause. Now, in the case in which you don't have a full description, and so you don't have the common cause explanation of the correlations, it's still going to be true that the correlation doesn't hold under intervention on one side.
Yes.
You're not going to have the explanation for it, but it's if part of your locality condition is something like that the correlation holds under a free choice of one of the variables, then it's still going to fail in this case.
Okay. So you're saying that we put this free choice assumption in without really explaining how that variable of the free choice is associated to other things in the past. Well, I mean, my view of the freedom of settings thing, of course there are variables which influence our choices, but somehow you only have to consider things relevant to the experiment, and those things are irrelevant in some sense. But without the freedom of settings, I'm just going to retreat to what Bell said. Without the freedom of settings, I'm not sure how to talk about that.
I wasn't suggesting you should take out the freedom of settings. I just think given that you've got freedom of settings, these the kind of cases that described are not as problematic as they might otherwise.
Oh, I see.
So I was just wondering whether you could tell, I don't know if you've thought about this, whether you could tell a similar story about other negation.
With the,
for example, if somebody proposes a weakening of contextuality, then could you construct a sort of trap where you show that the distinctions that aren't supposed to cause a difference would show up in some
in a manifest way? I haven't thought about it in the case of you'd imagine so, just because of the similarities of the two problems, but no, I haven't thought about it. That's an interesting comment, yeah. So yeah, the answer is no, I haven't really gone into depth, but I suspect that something similar would be true for other no-go theorems, yeah.
Jeremy?
Well, I fear this may be Chris Simpson's question if he has one, but I was very much, endorsing everything you said, thanks for it, but I didn't get the logic of your comment about the, distant outcomes that are indefinite. It seemed to be an escape route that you were announcing wouldn't work. It was one of your coloured balloons that would be rejected as an additional adjective.
Yes.
Can you just go over?
Yes. Right, so let's see, quickly. Well, so you remember the general form of the argument is just to imagine this person doing this and then trying to, so that the idea is supposed to be whatever the account of locality is, you should be able to apply it to all kinds of theories, and it should rule out all situations where you've got superluminal signalling. Otherwise there's something wrong with it, because lack of superluminal causal influence, which is what locality is supposed to mean, should rule that out. So in this case, first of all, someone would describe to me their version of CHSH, which would be, okay, what's happening in the other wing? The outcome on the other wing is indeterminate, so there's no issue of, so that the argument is supposed to be there's no issue of a correlation which needs to be explained between my outcome and Bob's outcome, if I'm Alice. And then I'm saying, okay, I can take all the words that have been said there in defense of locality and apply them to this case, or not this case, that's the case I just mentioned, the CHSH one. I can take all those words and apply the same account to this case where I've got a setting to switch from +1 to -1 and Bob just has an outcome, and say something like, there's no case to answer here, there's no correlation between me and this space-like agent because his outcome is indefinite. So I'm imagining now, having seen in this hypothetical situation a real superluminal signalling going past, I'm imagining someone theorising about it and saying, because I have this ontology, I don't think that there's anything wrong with this, and I think this is all local. And they're saying, because Bob's reception of this signal is actually indefinite, you can't say that there's a correlation here that needs to be explained at this stage. It's only when they meet in their future light cones that we find out about the correlation anyway, these two people. Then Bob gets measured by Alice or something. And so I'm using all the same words that people use in their description of the CHSH experiment and that whole account of locality to defend a situation where there's superluminal signalling, and thus there's a sort of contradiction. Is that helpful, or is that still...
Thank you, helpful, yeah.
Okay.
Chris, what's up your question?
Yeah, not quite, but it's closely related. So partly it's a dialectical diagnosis. So what Harvey and I were trying to do was to argue how it's possible that violation of Bell inequality didn't entail non-locality, and so we were answering a how possible, not a why necessarily question. And the other thing you might say, if the challenge is, what is it about our story which guarantees that no signalling is going to hold? You might say, well, actually, there's a common cause or a common explanation here. It's the structure of quantum theory and the fact you've got local Hamiltonians, which explains both why Everett is true if you buy this full-blown realism story, which we don't endorse, we're just saying it as an option if we want to take seriously. Right. You have an explanation of how the whole thing is going to go. It's just looking at how the state evolves over time. And it's not the case that anything done over here actually changes anything instantaneously over here, which is one of the findings factor. But at the same time, you have a complete story of how all of these things evolve and how it's also going to be the case that when they get together in the joint future, they are actually going to have these correlations which violate the Bell inequality. Yes. So a common cause for the story about the lack of definiteness on one side with respect to the other, because that's just what follows from the structure of realist quantum theory, unitary realist quantum theory. We have locality also because of the Hamiltonian's local, which is going to be crucial, and no signalling just drops out from the structure of quantum theory. So I think the trap's really cute, but I'm not feeling it snap.
Right. So there's this. So So I think maybe there's not so much of a disagreement. I mean, if you want to explain the lack of superluminal signalling by appealing to the structure of quantum theory, that's a mode of explanation which is fine. But I'm saying that what we're really trying to do is have a more powerful type, or what I think is a more powerful type of explanation, which is a bit, not exactly theory independent, but less theory dependent, I suppose, which is this causal mode of explanation. I'm saying that's the one that's gone wrong. So of course, yes, you can appeal to quantum mechanics and say that's why there's no superluminal signalling because of this theory I've got. But there's nothing wrong with that. But I was saying that Bell's notion of locality was really angling at some deeper form of explanation, which I think is not working in this kind of scenario. Although there's still some nice things about it. And yeah, so I wasn't exactly attacking the whole argument, but just sort of this, sort of looking at it as a way of getting around the fundamental problem that's posed by Bell's theorem, basically. So I'm not sure it's really in that much disagreement with it. So yeah.
Okay, Pete?
Yeah, so I just wanted to get clear on what exactly the trap is and what exactly is wrong with it, blah, blah, blah. You say, well, if it doesn't rule out superluminal signaling, then what good is it? Right? Well, take the zigzag version. Right? You might say, well, here's what good it is. You can state it without specifying a preferred frame. That's what good it is. But then it doesn't rule out superluminal causation, so you've got to add something else.
Yes.
But, yeah.
Right,
okay.
so I didn't say...
Okay, so I've got to add a second element, but at least I...
Right, so that... yeah, exactly. So I'm not saying... So I tried to sort of add a caveat. I wasn't really saying what good is it. All these ideas should be booted out of the door. Because, there might be other things. I was saying that they don't... There's something about the conundrum of Bell's theorem is really about causal explanation, and here's something's going wrong with that. But... like you say, there might be something really good about retrocausation. Some of those things that I said we want to achieve are true there, so you can have a relativistic description. It might prompt you to add extra detail to the past, which is something you might want to do for theory development purposes. So it might do a lot of good things, but I still think how it's going about, it's just that there's not really a good account of the lack of superluminal causal influence there. Right. And that's what Bell's theorem is about. And that's so I don't think you should call it local in the Bell sense, because that's
it's
what he meant.
It's
local in some sense, if you like, but it's the why people keep banging the word local about. I think it's really because of Bell's theorem, and so it's not just a nomenclature thing. It's something to do with the heart of the matter of Bell's theorem to me.
Ken has
Yeah, that was almost exactly my question that you just asked. But that's what you just said. What Bell's theorem is primarily about. Focusing on explaining why you can't superluminal signal, but the other half of what it's about is explaining why there are the correlations. Well, let's not forget that. That's it. In fact, I would say that's more important because that's an active thing that needs explanation rather than explaining why something doesn't happen. So if you have those two things you need to explain, I'm actually more focused on explaining why the correlations are the way they are, more so than explaining why the signaling isn't there.
Right, so the thing is trying to trap between those two things. So I was saying if someone comes along with a nice explanation of CHSH, then I'll use the same words to force them over the edge of this cliff. So you're quite right. I mean, it does explain why there could be more correlations than just the local ones. So yes, if you again, so I wasn't attacking the entire notion with just this thing, which I think is Bell's theorem is about why you're in that weird space, and or something. I don't want to take up too much time, but there's lots of other interesting questions in that little space between local and superluminal signalling as well. Why is quantum an intermediate place, and why is it why can you get exactly the correlations there that you can get? And that's not something that's so much discussed in the philosophical community, but it's something that's very much discussed in the quantum information community, and maybe that's something we should bring together at some point.
Okay, we've got a couple of questions, so we'll have to be quite brief. James?
Yeah, just wanted to take issue with something you said. I'm sure you know this. Well, you do know this, but you said if we have these space-like correlations, there's nothing more we can say. We just have them, right? But there is more we can say. We can say, all right. So I bet there's two systems in those two distinct regions that were once together, and were subject to some entangling Hamiltonian, because we know that we can't have entanglement increased by local operations and classical communication. So Well, moreover, there's the whole theory of quantum states and the fact that there are these entangled states and we can quantify the amount of entanglement in different states and so on. So it's not like we have no physics about these space-like separations.
Yeah. It's just that, yes, exactly, yeah, so maybe I overemphasised that, so I think this goes back to something this goes back to what Chris was saying as well, and I've had this conversation with Howard at some point in the past where, yes, there are explanations you can make why there's this correlation there, well, you could say it in an operational way, well, it's because I know about quantum theory, I knew that when I went to the lab and set up this thing to make some singlet states, that's why something like that must have happened, or someone must have done that, or some physical process did that. But then that's a theory-based explanation, and I was going after some kind of causal explanation, which I think is a different, stronger thing, which...
Right,
so,
it seems to me that what you're saying is, well, we need a causal explanation to be one where the common cause screens off the correlation and the effects.
Well,
But that's, in a sense, we might think, well, what we've learned is that there are common causes, it's just they don't screen off correlations between their effects always.
But then you haven't got, so then there's no causal account of things. There's an account of it via your theory, but you don't have a causal account of why these things are correlated. Right? So it's not really a causal thing. It's just, I mean, you can say like I caused it by making my singlet in the lab, but it's a sort of different. It's really reliant on that particular theory, and if you were trying to build more theories or generalise, you.
But what more would it be? I mean, what else do you want from a causal explanation than lots of scientific theories that explain how the causes work? I mean, you want some sort of causal explanation that's independent of a scientific account of how things work? Because I kind of think if you give the scientific theory, what you're doing is giving our best account of how the causation works.
But I want something that can go from theory to another theory. So say you see two trees wiggling at the same time, and they always wobble at the same time, and they're still at the same time. And say I had no theory at all. I might say, oh, there must be wind, and there must be some wind which is making both the trees wobble at the same time. So I add wind to my description of reality. That's a sort of a dynamic thing. I've gone from a very bad theory to a slightly less bad theory. Right? And that's not all contained in one theory. So say now I want to go from the theories we have now to a better one, maybe quantum gravity or something. Now, if I only have the description, the explanation from quantum mechanics, that doesn't help me to generalise. I think that what I want is something more powerful than that, which could point the direction to new theories and would still be true in a variety, in a landscape of theories, which I want to explore. So that's why.
Okay, and left.
You cannot formulate Bell inequality in many word interpretations, so I was not surprised that you didn't raise it in the beginning, but then there is this slide, which I think is just incorrect, which I don't understand its role. First, there is no superluminal influence in many words, and here, for you, the measurement result in the distant wing is definite, not indefinite.
Well, you can debate some of that with Chris. I think certain people say if you're one of the Alices, you don't really. There's not. You're not in one of the particular branches of this. But I'm not
your
really
measurement
world's
result
person.
is only true in one branch. For you, the measurement result in distant wing is definite. I assume that they measure in the same basis.
Oh, okay. So then you'd say, well, if they're in the same basis, you might say, yes, there's only one. But if you condition on what you've got over there, there's one over here. But say it was a slightly different basis or something, right? That's
anyway,
well, this
you
is.
say it's trapped for many worlds. In which way?
Well, I'm just giving an account which someone else has given for many worlds, which is he's over there. So I'm repeating things. So I'm here using Chris and Harvey's account of causation in many worlds and laying a trap for that. But I mean, to some extent, when you say that there's no superluminal influence, again, I have to question what it means, no superluminal causal influence, if you haven't used Bell's definition, and what is it? And secondly, maybe the reason why you can't fit many worlds into Bell's framework is, well, if you can't have probabilities attached to things living in space-time, then you're in trouble. And that's why I don't believe in many worlds.
There is no definite outcome in one branch, not in the distant one. In your branch, there is no definite outcome. This is a problem.
No. I think we need to bring the Q&A to a close, and
okay.
this can continue later. And we'll move on to the next talk, and thank again.